All right. Continuing where we left off, this is section 10.2, chemical equilibrium. All right. In chemical equilibrium, what is happening is initially you have here hydrogen and iodine, all right? And then they're reacting, bonds are being broken between them, and hydrogen iodide molecule is forming, all right? So initially, there's no product, no hydrogen iodide. It's just going to go forward. So that's the forward reaction. Eventually, there's a point that is being reached where some of that hydrogen iodide is then reacting with each other and going the reverse direction where they're forming back the initial reactants. All right. So that's the reverse reaction. Now, the rate going forward, if it equalizes with the rate going reverse, that is called as equilibrium. At equilibrium, the forward rate is equal to the reverse rate. However, the concentrations of the reactants and the products are not equal. They're just constant. All right. So this is a key point to remember. All right, so this is called as a reversible reaction because of the fact that you have a double arrow indicating that it's both going forward and in the reverse direction. So there's two kind of equilibriums you can write. You can write an equilibrium showing the forward reaction where the hydrogen iodide is the product, or you can flip this equation where hydrogen iodide is forming hydrogen and iodine. And that would be the reverse of the flipping of this particular equation where now hydrogen and iodine become the products and hydrogen iodide is the reactant. All right. So a reversible reaction is where the forward and reverse reaction rates are the same. But the reactant and the product concentrations are not equal, they're constant. All right. So it says here, write the forward and reverse reactions for the following. So you're given methane and hydrogen sulfide forming carbon disulfide and hydrogen. All right. So the forward reaction would be written this way. The reverse is where you would flip this equation and make the products into the reactants. And so as you can see here, forward reaction is as it's written up there. And then the reverse reaction is where you took the original products and made them now into the reactants. And then the original reactants are now the products. All right, so this graph shows you that when you're charting the reaction rate versus the progress of the reaction, you will see that the rate of the forward reaction is constantly dropping and the rate of the reverse is picking up until they reach a point where both rates are equal, and that's equilibrium. And if you look at product concentration, the square bracket around the products or the square bracket around the reactants, the square bracket indicates concentration. All right, you can see the concentration of the products gradually increasing, the concentration of the reactants gradually decreasing, and then at equilibrium you can see they need not be equal, but they are constant, and that's why that flat line. All right. This is shown well with this particular picture. You can see in this picture you have 4 nitrogens, the purple molecules, and then 4 hydrogens, all right? No product because it's 0 time, all right? After an hour, you'll see that 2 of those hydrogens and 2 of those iodines have reacted and formed 2 molecules of HI, all right? So now the hydrogen is reduced to 3, the iodine to 3, all right? Now after the second hour, you'll see that 2 more of the hydrogen iodide molecules have formed. All right, so now you have 1, 2, 3, 4 of the hydrogen iodide, 2 each of the iodines and 2 of the hydrogens. All right, so their concentrations have been reduced by 2. Now, after the third hour, you'll see that there's only 1 of the hydrogens and 1 of the iodines. The rest of the 6 molecules present are hydrogen iodide, all right? after the 8th hour, you'll see that it's exactly the same as after the 3rd hour. So that means that at the 6th hour is where equilibrium was established, and the concentrations of the reactants and products have not changed since. All right. So that is when the rate of the forward and reverse reactions are equal, and therefore the reactant and product concentrations have not changed. So in this reaction, the forward reaction is H2 and I2 forming the HI. Reverse would be the HI forming hydrogen and iodine. All right. So as that HI product is building up, the rate of that reverse is kind of increasing. All right. Whereas the rate of the forward is decreasing. All right. So at equilibrium, those rates are equal and no further changes takes place in the concentrations of the reactants and products. All right, complete the following with is R equal or is R not equal, changes or does not change. Before equilibrium is reached, the concentrations of reactants and products are not equal. Are concentrations of reactants and products does not change. No, changes. I'm so sorry. Before equilibrium is reached, the concentrations of the reactants and products changes, and they are not equal, of course. Okay. At equilibrium, the rate of the forward reaction is is equal to the rate of the reverse reaction. All right. So they are equal. All right. At equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. All right. All right. So I made it more complicated. So before equilibrium is reached, the concentration of the reactants and products does change. At equilibrium, the rate of the forward reaction equals the rate of the reverse reaction. All right, in this particular slide, you can see you have oxygen and then you have sulfur dioxide. All right, this is green is the sulfur, those are the two oxygen atoms. So you have 1, 2, 3, 4, 5, 6 molecules of sulfur dioxide, 3 molecules of oxygen. All right. So initially there's no product, and then the reaction goes forward, and then you see that one of those oxygens is broken down and combined with two of these sulfur dioxides to form sulfur, or rather four of these sulfur dioxides to form sulfur trioxides. All right. Okay. So out of the six, four of them have formed sulfur trioxide. Okay. Two of the oxygens are depleted, and only one oxygen and one sulfur dioxide remains. Now, then some of that sulfur trioxide will start breaking up to release sulfur dioxide and oxygen. However, in the final reaction condition, you see a lot of sulfur trioxides. All right, they seem to be dominating the equilibrium solution rather than the oxygens or the sulfur dioxide, the initial reactants. All right, so when the product is dominating the equilibrium mixture, that means that the forward reaction is greater than the reverse reaction. All right, so in the reverse reaction, yeah, some of the sulfur trioxides are breaking down, but you can see that the equilibrium mixture has more sulfur trioxide compared to the sulfur dioxide and oxygen, the original reactants. All right, so in this case, the equilibrium is favoring the forward reaction. Okay. All right, reactants form products in the forward reaction. At equilibrium, the reactant concentration does not change. Products form reactants in the reverse reaction. All right, we will stop here and continue this in the next video.